Okay guys, so it finally happened and Mr. Fies ended up dying. When we found him at 6 p.m., his body was 80 degrees. Now the room with the temperature was 70 degrees. And then when the police arrived, his body was 75 degrees, which was at 7 p.m. So, in order to find the elapsed time between time of discovery and actual time of death, we must first find the values of K and T. To do that, we'll be using Newton's law of cooling. Now, Newton's law of cooling states that the temperature is equal to the temperature of the room plus, open parentheses, the temperature of the object minus the temperature of the room, close parentheses, multiplied by E raised to the negative K times T, which is the time. So, let's get started. We've got the temperature of the room, which is 75 degrees, is equal to the temperature of the room when we found him, which is 70, plus the temperature of the object at the time, which was 80 degrees, minus the temperature of the room, which is 70 degrees, times E raised to the negative K times T. Now, we're just going to be using simple algebra here, subtracting 70 from both sides, and then subtracting 80 minus 70. This should give us 5 is equal to 10e negative k t. Alright, the next thing we're going to do now is divide both sides by 10. Now we have 1/2 is equal to e to the negative k times t. Now, we're going to ln both sides. Now, if you know anything about algebra, I wrote it down here. The ln of e is equivalent to the log of e. The log base e raised to e is equal to 1. So when we're lnning an e, we're canceling them essentially. So ln of 1/2 is equivalent to ln of e negative k times t. These cancel. We get ln of 1/2 is equal to negative k t. So what we're going to do now is, because the time of elapse is 1 hour, we're going to say that t is 60 minutes. ln of 1/2 is equal to negative k times 60. We do simple algebra, divide by negative 60 on both sides because we want a positive k. And we get k to be equivalent to 0.116. Alright, good. We got the first step over and done with. I'm just going to erase all this and start step 2. Alright, now we can find the elapsed time between the time of discovery and the actual time of death. So, let's start right here. We're going to use 80 degrees now because that's the time at 6 p.m. when we found Mr. Fies' body. The temperature of the room was 70 degrees. And a normal person would have a temperature of 98.6 degrees. So we're going to use that. And it's just the same process all over again, except now we have k, and that can help us find our unknown t. We do simple algebra again, subtract 70 from both sides, and then we're going to subtract 98.6 minus 70. We get 10, which is equal to 28.6 times e raised to the negative 0.116 times t. We divide both sides by 28.6, and then we're left with a fraction. And e all by itself with k and t. So we're going to do what we did last time and raise both sides by the ln. Again, like we stated before, the ln cancels e and makes it 1, giving us negative 0.116 times t. All we have to do now is divide. And to save us a lot of trouble on calculator, I'm just going to tell you what the answer is already. T is equivalent to 90.54 minutes. We round this to the 10th and we get 90.5 minutes. And let's just round it up again so we get a better number on the overall time. And we're going to get 91 minutes overall. So now we have found the elapsed time between time of discovery and the actual time of death. So let's convert this to make this easier on ourselves. We know that 60 minutes is equal to 1 hour. Now, 91 minutes, that's going to give us a remainder of 31. So 91 minutes is equal to 1 hour and 31 minutes. Now that we have all the information, we can subtract this from the time that we found Mr. Fies' body, and that'll give us the time of death. We're going to move this all the way up here, and we're going to get 6 p.m. subtracted by an hour and 31 minutes. You subtract the 1 hour, you get 5, and then you subtract 31 minutes, and that'll leave you with 4:29 p.m. as the time of death. And there you have it, boys.